Okay, hello, good evening, or good morning, whatever time it is that you're watching this. Okay, so today I'm going to explain about the formation of dative bond. In this case, I'm going to use ammonium ion as my example. Okay, first things first, you must know what is the definition of dative bond itself. So I'm just going to read out from the textbook. So it says that dative bond, or other name for it is coordinate bond. It is a type of covalent bond where the electron pair that is shared comes from only one atom. We know that covalent bond is the sharing of electrons between two nonmetal atoms. Okay, so but in this case, the electrons that are being shared comes from only one atom, meaning that the other atom does not contribute any electrons to this sharing. Okay, that is the first part. Okay, now we know that ammonium ion, no, that's not ammonium ion. The ammonium ion, NH4 plus, it is derived from ammonia, right? Okay, and we know that the chemical formula for ammonia is NH3. So if you were to draw the structure of NH3, it would look like this. Okay, now we look at one by one. We look at this nitrogen atom. So we know that nitrogen is in group 15, meaning that it has 5 valence electrons. So you can look at this 1, 2, 3, 4, 5. The blue ones are the valence electrons of nitrogen. Okay. And in an ammonia molecule, we know that this nitrogen atom, it forms 3 covalent bond with 3 hydrogen atom. So look at this one example here. This hydrogen atom, it consists of only one valence electron. So to achieve stability, it must need another one valence electron, right? Okay, so in this case, hydrogen atom shares one of its electron, or its only electron, with this nitrogen atom, so that they both achieve stable electron arrangement. In this case, hydrogen atom now it has achieved stable duplet electron arrangement. And meanwhile, for nitrogen atom, since it forms 3 covalent bond with 3 hydrogen atom, so now it has 8 valence electron. So it has achieved stable octet electron arrangement. Okay, that is the explanation for the structure of ammonia. Okay, now if we look at this structure, this one pair is occupied, this one pair is occupied, this one pair pun is also already occupied. Now we are left with one lone pair of electrons, which is not occupied. Okay, so this is our lone pair of electrons. Okay, now we look at this hydrogen ion. Okay, we know that hydrogen has one valence electron, or the valence electron is the only electrons it has, because we know that hydrogen is in period 1, group 1. So it only has one electron, which is its only electron. So it has one electron, meaning that it has one proton. Right, okay. Now this is a hydrogen ion, meaning that it has loses the electron. Or in another word, it loses its only electron that it has. So this structure right here, it does not carry any electrons at all, or we can say it as electron deficient. So this structure right here is positively charged, and this lone pairs of electrons right here, this lone pair of electrons right here is negatively charged, and we know that negative attracts positive, right? So this lone pair of electrons will be attracted with these hydrogen ions. Okay, and then therefore we're going to form this structure. Okay, we know that this one does not has any electrons in it. So in order to achieve stability, it must need to form a type of bond so that it achieves stability. So in this case, it forms a bond which is dative bond with this lone pair of electrons, so that it achieves, in this case it's 2. So now this structure achieves stable duplet electron arrangement. Okay, now it forms this structure. If you were to draw the ammonium ion structure, it's going to look like this. Don't forget your bracket and this positive symbol here. Okay, now I'm going to talk about why this ammonium ion is positively charged. You may have guessed it or you may have not guessed it, so I'm going to explain it. Okay, we know that in this structure, we have, nitrogen atom, we have 1, 2, 3, 4, 5, 6, 7. We have 7 electron, which is equivalent to 7 proton. Okay, and then when it forms a covalent bond with the hydrogen atom, meaning that the number of electrons increases by 3. 1, 2, 3. So right now we have 10 electrons, which is equivalent to 10 protons. Okay, so in this structure we have 10 protons and 10 electrons. Meanwhile, in this structure over here, like I said just now, it does not carry any electrons with it, but it carries 1 proton with it. So in this structure we have 1 proton but 0 electron. Okay, so when it forms the dative bond and we form this structure, so right now in this structure the number of electrons that we have remain the same, since this one does not carry any electrons with it. So in this structure we have 10 electrons, but the number of proton increases since this one carries 1 electron with it. It's 1 proton with it, sorry. Okay, now our proton number increases by 1. So we have 11 proton and 10 electrons. Therefore, we have one extra positive charge, right? So this whole structure right here is positively charged. So that is basically the reason to it why is ammonium ion positively charged. And basically that is all for the formation of dative bond in ammonium ion. If you have any other questions, feel free to hit me up. I'll try to answer. Okay, bye bye.